Hello everyone, my name is Rajesh. I am from CSC section. Today's my topic is about syntax directed translation. Introduction. Parsers uses a CFG context-free grammar to validate the input string and produce output for the next phase of the compiler. Output could be either a parse tree or an abstract syntax tree. Now to interleave semantic analyze with the syntax analyze phase of a compiler. We can use the syntax directed translation. Input string and input string is converted to parse tree and parse tree is converted to dependency graph and dependency graph is converted to evaluation or for semantic rules. Conceptually, with both the syntax directed definition and translation schemes, we parse the input token stream, build the parse tree, and then traverse the tree as needed to evaluate the semantic rules at the parse tree nodes. Evaluation of the semantic rules may generate code, save information in the symbol table, issue error meanings, or perform any other activities. The translation of the token stream is the result of obtaining the evaluated the semantic rules. Definition. Syntax-directed translation has argumented rules to the grammar that facilitates a semantic analysis. SGT involves passing information bottom-up or top-down to the parse tree in form of attributes attached to the nodes. Syntax-directed translation rules use lexical values of nodes, contents, and attributes associated with the non-terminal in in there. The general approach to syntax-directed translation is to construct a parse tree or syntax tree and compute the values of attributes at the nodes of the tree by visiting them in some order. In many cases, translation can be done during parsing without building an explicit tree. Example, E tends to E plus T or T tends to T star F or F tends to int lift. This is a grammar to synthetically validate an expression having additions and multiplications in it. Now, to carry out semantic analysis, we will argument STD rules in this grammar in order to pass some information up the parse tree and check for the semantic errors if any. In this example, we will focus on evaluation of the given expression as we don't have the semantic assertions to check in this very basic example. E tends to E plus T. Here E dot val is equal to E dot val plus T dot val. E tends to T means E dot val is equal to T dot value. T tends to T star F means T dot value is equal to T dot value into F dot value. T tends to F means T dot value is equal to F dot value. F tends to in intlift means T dot value is equal to intlift dot lexful. For understanding translation rule further, we take the first SGT argumented to E tends to E plus T production rule. The translation rule is considered in consideration has value as an attribute for both the non-terminal E and T. Right hand side of the translation rule corresponds to attribute value of the right side node of the production rule and vice versa. Generalizing SGT are argumented rules to the SFG that associate a set of attributes to every node of the grammar and a set of translation rules to every production rule using attributes, constraints, and lexical values. Let's take a string to see how semantic analysis happens. Let's take an example S is equal to 2 plus 3 into 4. Parse tree corresponding to S would be to evaluate here. The image shows the parse tree of the given expression. To evaluate the translation rule, we can employ the our one depth first search traversal on the parse tree. This is possible only because SDT rule doesn't impose any specific order on evaluation until children's node are computed before parents of the grammar having all synthesized attributes. Here is the image shows the parse tree of the given expression. E tends to E tends to uh, E is divided into 2 E plus T, and T is transformed into T, and T is transformed to F, and F is transformed into 2. Otherwise, we would have to figure out the best suited plan to traverse through the parse tree and evaluate all the attributes in one or more traversal. For better understanding, we will move bottom up in the left to right fashion for computing the translation rule of our example. The diagram here is a diagram shows how the semantic analysis could happen. The flow of information happens bottom up, and all the children's attributes are computed before parents, as discussed above. Right hand side nodes are sometimes associated with the subscript 1 and distinguish between children and parents. Here is the image shows the uh, way here is the image shows the way that we need to evaluate the parse tree. Synthesized attributes. Synthesized attributes are such attributes that depends only on the attribute value of the children nodes. Thus, E tends to E plus T is that is E dot value is equal to E dot value plus T dot value has a synthesized attribute value corresponding to node E. If all the symmetric attributes of the augmented grammar are synthesized, one depth first search traversal in any order is sufficient for the semantic analysis space. Inherited attributes. Inherited attributes are such attributes that depends on the parent and or siblings attribute. Thus, E tends to E plus T. That means EP value is equal to E dot value plus T dot value, where T dot value is equal to EP dot value, where E and EP are same production symbols annotated to differentiate between parent and child has an inherited attribute value corresponding to the node T. Types of attributes. Attributes may be of two types, synthesized or inherited. Synthesized attributes. A synthesized attribute is an attribute of the non-terminal on the left-hand side of the production. Synthesized attribute represent information that is being passed up the parse tree. The attribute can take value only from its children, variables in the RHS of the production. For example, let's say A tends to BC is a projection of grammar, and A's attribute is dependent on B's attribute, and C's attribute is then synthesized attribute. Inherited attributes. An inherited attribute is of a non-terminal on the right hand side of the projection is called the inherited attribute. The attribute can take value either from its parent or from the siblings. Variables in the LHS or RHS of the production. For example, let's say A tends to BC is a production of grammar, and B's attribute is dependent on A's attribute, or C's attribute is then it will be inherited attribute. S attributed SDT. If an SDT uses only synthesized attributes, it is called a S attributed SDT. S attributed SDTs are evaluated in bottom-up parsing. as the values of the parent nodes depend upon the values of the child nodes. Semantic actions are placed in the rightmost place of the RHS. L attributed SDT. If the SDT uses both synthesizer attributes and inherited attributes, with the restriction that inherited attributes can inherit values from the left sibling only, it is called a attributed SGT. Attributes in L attributed SGT are evaluated by depth first and left to right parsing manner. Semantic actions are played anywhere in RHS. For example, A tends to XYZ, where Y dot S is equal to A dot S, Y dot S is equal to X dot S, Y dot S is equal to Z dot X, is not the L attributed grammar since Y dot S is equal to A dot S and Y dot S is equal to X dot S are allowed, but Y dot S is equal to Z dot S is violated. The L attributed SGT definition as a attributed is inherited the value from the right sibling. Note, if the definition is S attributed, then it is also L attributed, but not vice versa. Here is the image showing that the S attributed is a L attributed, but every L attribute is not S attributed SGT. Example, consider the given below SGT. P1 S tends to Mn, S dot value is equal to M dot value plus N dot value. P2 is equal to M tends to PQ, M dot value is equal to P dot value into Q dot value, and P dot value is equal to Q dot value. Explanation. In P1, S is synthesized attribute, and in L attributed definition, synthesized is allowed. So P1 allows the L attributed definition, but P2 doesn't follow L attributed definition, as P is depending on O, which is RHS to it. Thank you.